Welcome back, dear students. In session 3, we'll continue with exercise 4.2 of quadratic equations. In today's session, we'll learn the method of finding roots by factorization. Okay? How to factorize the given quadratic equations, and we'll see few application questions where we can use quadratic equations. So let's begin with the first question. Find the roots of the following quadratic equations by factorization. So the quadratic equation given to us is x square minus 3x minus 10. So we will factorize this by splitting middle term. So what is the middle term in this? The middle term here is minus 3. And the product of first and last term. Okay, always remember the rules of factorization. We find the product of first and the last term, that is minus 10. Okay, and the middle term is minus 3. Okay, so we will find two numbers whose sum is minus 3 and product is minus 10. Okay, so we need to find two factors, two numbers whose sum should be minus 3 and product should be minus 10. So that for that I can take minus 10 1, minus 2 5, 10 ones is 10. Okay, 10 ones is giving me minus 10, but it is not giving me minus 3 as sum. Okay, means I am getting with 10 ones I am getting 10, but I am not getting minus 3 with it. Minus 10 plus 1 is minus 9. Okay, so we can't take these factors. Then we'll see with minus 2 and 5. Minus 2 and 5 also can give me minus 10, but when I add these I'll get plus 3. Okay, what I need minus 3. So very carefully you need to take the factors. So let's go for 2 and minus 5. Now you see the middle term is negative, so 2, the larger number should be negative here. So 2 and minus 5 will give you, the sum of these two will give you minus 3, and 2 5s is 10. Okay, so finally I select these two factors, 2 and minus 5. Okay, 3 minus 3 can be written as 2 minus 5, and 10 can be written as 2 into minus 5. After finding the factors, after finding the factors of 10, let's substitute it here. So minus 3 can be written as 2 minus 5, 2x minus 5x. Now we'll take common from here. From this 2 I can take x as common, remains x plus 2, and from here I can take minus 5 common, remains x plus 2, because when we take minus a number common with the minus sign, okay, this becomes plus. Again, if you open the bracket, you can see that minus 5x minus 5 into 2 is minus 10. Okay, so this is very important part of this problem, finding the proper factors. Okay, taking proper numbers. If you take the wrong numbers, okay, you may not get correct answer. Now from here I can take x plus 2 common again. X plus 2 is common, remains x minus 5. So x plus 2 and x minus 5, these are the two factors. X minus 5 equals to 0, x is equal to 5, and x plus 2 is equals to 0, x is equal to minus 2. So these are the two factors of the quadratic equation. This way we have to follow for solving quadratic equations by using splitting middle term method. We have another method in this chapter, that is called quadratic formula. Okay, we can even factorize by quadratic formula also. So let me teach you quadratic formula, the same problem with quadratic formula. Okay, how we can get these two values with quadratic formula. Okay, so the question here is x square minus 3x minus 10. The question is x square minus 3x minus 10. Okay, the first thing what we do here is we compare this with uh, standard form of quadratic equation, ax square plus bx plus c. Okay, so comparing this with the standard form, we can get a, b, c values. So here what is the coefficient of x square? If there is no number, it is 1. Coefficient of x is minus 3. So a is 1, b is minus 3, b is minus 3, and c is minus 10. Okay, this is c. So first we find the coefficient, we find the values of a, b, c. Now we can simplify, we can factorize this type of equations by using quadratic formula also. Okay, so let's see what's quadratic formula. Quadratic formula is x is equals to minus b plus or minus, okay, plus or minus under root b square minus 4ac by 2a. This is quadratic formula. We can even use this formula to factorize. So what we need to do is just substitute these a, b, c values in the formula. Okay, so if I substitute the values, I get minus b. What is b value here? B is minus 3. So I get minus of minus 3. Then plus or minus b square minus 4ac. Okay, so we'll find this value b square minus 4ac separately. Let's find b square minus 4ac value. What are abc values here? 1 minus 3 minus 10. Okay, so we'll find b square minus 4ac value here. B square minus 4ac. This is called discriminant. So b, what are abc values? We have taken just now 1 minus 3 minus 10. Okay, so a is 1, b is minus 3, and c is minus 10. So we'll first find the value of this. This is called discriminant. Okay, denoted by d, discriminant. So b square is minus 3 square minus 4 from the formula. Then AC, A is 1 and C is minus 10. Okay, C is minus 10. 3 square minus 3 square is 9. This minus into minus becomes plus. Okay, minus into minus becomes plus. 10 fours are 40. So finally we get 40 plus 9, that is 49. This is the value of D, discriminant. This is called discriminant. Okay, so I can put this value in place of b square minus 4ac and proceed with the next part. So here I got b square minus 4ac as root 49 by 2a. 2a is 2 into a is 1. Okay, in the beginning it may look quite difficult to you all, but this is the simplest method of finding factors by using quadratic formula. Once if you understand the method, you can factorize any quadratic equation. Now after this, let's continue with it. So what we have got here, we got minus of minus 3 plus or minus root 49 by 2. So minus of minus 3 becomes plus 3, root 49 becomes 7. Root of 49 is 7 by 2 into 1. Okay, minus of minus 3 becomes plus 3. 49 is 7 and 2 ones is 2 by 2. So we get two values here. One is 3 plus 7 by 2. Another is x is equal to 3 minus 7 by 2. 3 plus 7 is 10 by 2, that is 5. And 3 minus 7 is minus 4, and that is equal to minus 4 by 2 is minus 2. Okay, so we have got the value of x and y, x as, sorry, not x and y, x as 5 and minus 2. We got the same answer even by this method, 5 and minus 2. Okay, so you can either do it by splitting the middle term, or you can do by quadratic formula. Okay, this is the way we can apply quadratic formula. In the same way, we can proceed with the next other remaining questions of this remaining bits of this question. Find the roots of the following quadratic equation by factorization. If method is not mentioned, you can apply any method. Okay, but here we are doing by factorization method. So here the product of first and last term is 2 6 times is minus 12. So the product of first and last term is minus 12, and the middle term is 1x. Okay, so we should find the factors, two numbers whose sum should be 1 and product should be minus 12. So what could be the factors? Can it be 3 and 4? Because 3 and 4 gives me 12. 4 3 times is 12, and 4 minus 3 is 1. Okay, whereas if I take 6 and 2, I may get 6 2s are 12, 6 2s is 12, but sum is not 1. 6 minus 6 plus 2 is minus 4. Okay, so we select 4 and minus 3 as the factors for splitting. So x can be written as 4 minus 3, 4x minus 3x. 4x minus 3x, by splitting I have splitted it. Now we take common from the first two terms and the last two terms. Taking common from here, I can take 2x as common. When I take 2x from here, I get x plus 2, and from the next two terms I can take minus 3 common. Here also remains x plus 2. Okay, we have done many questions of this type in 8th class. Now taking x plus 2 common from here, again x plus 2 and x plus 2 remains is 2x minus 3. Okay, you need to be very careful while you are finding the factors. So finally we get the values of x as 2x is equals to 3, x is equal to 3 by 2, and x is equals to minus 2 by transposing this to the right. This can be done with quadratic formula too. Okay, for your practice you can do the same problem by quadratic formula also. In the same way you can try the other question. Okay, now in this question, if we do by using quadratic formula, it will be very simple. Okay, if we do by splitting middle term, okay, we need to be very careful while taking the factors. Okay, so here if we multiply the first and the last term, that is 2 root 2 into 5 root 2, root 2 into 5 root 2, 5 root 2 into 2, 5 root 2 into 2. Okay, what will be the answer for this? Root 2 into root 2 is root 4, that is 2. 5 2 times is 10. Okay, so the product of first and the last term is 10, and the middle term is 7x here. So I can take the factors as 2 and 5, because 2 plus 5 is 7 and 2 into 5 is 10. This middle term can be split as 2x plus 5x. Okay, now we have root 2 here, and here we have 2. So what should be taken common? Here the question arises. So root 2 can be written as root 2 into root 2. Okay, keep this in mind. Any number can be written like if I have 2, I can write it as root 2 into root 2. What is root 2 into root 2? That is root 4. It's again 2 only. So there is nothing wrong if I write 2 as root 2 into root 2. So 2 is written as root 2 into root 2, so that I can take root 2 common from here. So what's common here now? Common here is root 2 x root 2x. Taking root 2x common from here, from the first two terms, remains in the bracket is x plus root 2. Okay, so I'm taking root 2x common, remains root x plus root 2, and 5 is common from the next two terms. From here 5 is common, here also remains x plus root 2 if I take 5 and 5 common. Okay, then taking x plus root 2 common again, and we get our answer as root 2x plus 5 plus into x plus root 2. So x is equals to, x will be equals to minus 5 by root 2, or x is equals to minus root 2. This is the way we can factorize any quadratic equation, but every quadratic equation cannot be done by splitting middle term. Keep one thing in mind. But we can apply quadratic formula. Okay. Let's go for the third question of this exercise. Second question is an example. We can give it a try. We have to find two numbers whose sum is 27 and product is 182. So what could be the numbers? Find two numbers. Their sum should be 27 and product should be 182. Okay, it's like a game. Okay, so let's solve this puzzle. Let the numbers be x. Let the first number be x. Okay, find two numbers whose sum is 27. Okay, like let me give you an example. There are two numbers like 3 and 5. The sum of 3 and 5 is 8, and the product is 3 into 5, that is 3 5 times is 15. So like this, there is a question frame. The sum of two numbers is 27 and their product is 182. We need to find what are those numbers. So let us take the first number as x. Okay, so what could be the second number? If the first number is x, second number will be 27 minus x. Okay, like just now it gave you an example. Sum of two numbers is 3, that is 3 plus 5 is 8. Suppose if I know the first number is x, the second number will be 8 minus 3 or not. Okay, 8 minus 3, that is 8 minus x, right? If the first number is 3, that is I've supposed it as x, so the second number will be the sum minus the first number, that is 8 minus x, that is 5, that is 8 minus 3 5. So using the same procedure, we consider the two numbers as x and 27 minus x. The product of these two numbers is given as 182. So multiplying the first and the second number, we are getting 182. So let's multiply x and 27 minus x. Open the bracket, we get 27x minus x square is equals to 82. Transposing this to the right, it becomes plus x square minus 27 plus 182. Okay, make it as 182. It's not 82. So x square minus 27x plus 182. If we factorize this, just now we have done, we can use any method for factorizing. That's not an issue. So factorizing it by splitting the middle term. Sum is minus 27. Sum should be minus 27 and the product should be 182. So what could be our factors? It can be 13 14 times. 13 into 14 is 182, and 13 plus 14 is 27. So I take minus 13 minus 14. I follow the same procedure what we did previously and get our factors. So the two values of x is 14 and 13 by factorizing. Okay, so I can consider both the values. X is equal to 13. If x is 13, if the number is 13, then the second number will be 27 minus 13, that is 14. Or if x is 14, then the second number will be 27 minus 14, that is 13. So finally the two numbers are 13 and 14. If you add them you get 27, and if you multiply them you get 182. Okay, if you find difficulty in finding splitting the factor, you can find prime factors of 182. Okay, 2 9 times, 2 1 time. Okay, then 7 table. Okay, 7 1 time, 7 3 times. Okay, so multiplying this two we get 14, and here is 13. So 13 into 14. This way we can easily find the factors by doing prime factorization. So 14 into 13 is 182, and 14 plus 13 is 27. Just make a little change here. There is a misprint. It's 182. Okay. So this is the way we can use quadratic equations for solving different problems. Now let's go for the next question. Find two consecutive positive integers, sum of whose squares is 365. So what are consecutive positive integers? I gave you this example before also. Consecutive positive integers. What is consecutive of 3? It's nothing but 4. The next number, consecutive numbers. So I get next number by adding just 1 in the previous number. So let the number, consecutive number, be x and x plus 1. Okay, consecutive positive integers. Now he is telling sum of squares of these numbers. So we'll square them and add them. Okay, finding the sum of the squares. Square x, the first number and the second number. X square plus x plus 1 square is equal to 365. Means there are two numbers. When you find the sum of the squares, like let the two numbers be 2 and 3. Okay, I'll square them and I'll add them. What do I get? I get 4 plus 9. Okay, 4 plus 9 is 13. So like that there are two numbers. If we square them and add them, we get 365 here. Okay, we are getting 365. So we need to find what are those numbers. For this question also we'll try to frame a quadratic equation and factorize it. Okay. So this is the equation. Simplifying it further, applying a plus b whole square, I get a square plus b square plus 2ab. Then x square plus x square become 2x square. 1 square is 1, and 2 into x into 1 is 2x. Okay. Transposing 365 to the left, it become minus 365. 1 minus 365 is minus 364. I can take 2 common from here because these all are even numbers. So 2 is common, remains x square plus x minus 182. So we have got same number as a constant, that is 182. Just now we have taken the factors of 182 as 13 and 14. So factorizing this again by using any method, here when the product of the first and last term is minus 182 and the middle term is x 1x. Okay, so the factors can be taken as 13 and 14 here, but minus 13 plus 14. Okay, minus 13 and plus 14. Minus 13 plus 14 is 1, and minus 13 into 14 is minus 182. Taking these two factors, in place of x I can write 14 minus 13. Then again we follow the same procedure, taking common, and we get the values of x as 13 and minus 14. So the roots of the equation are 13 and minus 14. We have to find consecutive positive integers, so we take x value as 13. We'll ignore the negative value because it's mentioned in the question that find positive integers. Okay, so we'll take x is equals to 13. What would be the next number? X plus 1. Okay, the next number will be x plus 1, that is, sorry, here we are. So x is equals to 13. The next number will be x plus 1, that is 14. Okay, 13 plus 1, 14. So these are the two numbers, 13 and 14. When you square them and add them, you'll get 365. You can even verify it. Okay, so this is all about the second exercise. We have few more questions left over. You can try those questions. Okay, and take the notes regularly. Okay, any doubt, do get back to me. Thank you.